Hey y'all. All right, so we're going to talk some about quantitative skills right now. And I want to apologize because the slides are in a slightly off-kilter arrangement, so we're going to be jumping around a bit within quantitative skills because we're going to cover two different aspects of it. All right, first thing up though I want to talk about is I want to talk about measuring volume. And we often, if we're talking about measuring a solid, we're often going to use cubic centimeters or cubic meters, okay? Because if you're thinking about a solid and assuming it's in a cube, right, then or a rectangular prism of some sort, you just measure the length, width, and height, and then you multiply your centimeters across, so centimeter times centimeter times centimeter, that's a centimeter cubed. Definitionally within the metric system, that is the same as 1 milliliter, and sometimes centimeters cubed is abbreviated cc. All right. So if we are told that something is, oops, let me get my drawing up here. My bad. There we go. If we are told that something is 5.0 cubic centimeters, right? We just know that there is 1 milliliter to 1 cubic centimeter, and so it is 5.0 milliliters. Okay, so exact same identical units. And volume in general, if we're thinking about it, volume is really just the space, the amount of space occupied by an object. All right. We instead, or since we are often measuring liquids in chemistry, we instead will be using graduated cylinders typically to get those volumes. All right. We will come back, all right, to doing a variety of metric conversions, all right? But what we are going to talk about for the moment is we're going to talk about density, all right? So mass is essentially the measure of a unit, the measure of matter in an object, okay? And it's the unit that we will often use for this in chemistry is grams, all right? And then density is another property that you've probably run across, and this just gives us a sense of the amount of matter that an object takes up relative to the space that it occupies, right? So mass per unit volume, and it's a ratio, all right? So we can, in general, we can use it, all right, as an equation right there. Density is mass over volume, all right? And we can also look at it in terms of units. So what would be a typical unit we will run across in chemistry? Grams per milliliter, right? Mass in grams, volume often in milliliters. Many times if we're talking about density of gases, instead of grams per milliliter, we're going to talk about grams per liter, just because gases are so much less dense than liquids or solids. I will just briefly mention one of my pet peeves here. The liquid and solid packing densities here are completely off. Liquids and solids tend to have incredibly similar densities for the same material. And some materials, like water, for example, the solid is actually less dense than the liquid. That's why ice floats at the top of your glass of drinking water. All right. We're not going to worry about dimensional analysis with density right now. Okay, we will come back to that. But I did want to talk a little bit about graphing because we can use graphing also to figure out density, and we're going to be practicing that in the packet. We will do that together. All right. But if we are doing graphing, things that I want to make certain that you are doing in terms of your graphing is that you've got axes labels. Okay, often with units, all right, we got a title, all right, and many times not only are you going to be graphing data, and we've got equally spaced quantities, okay, on both axes, all right, and oftentimes you're going to have both scattered data points, so the actual data points, and a line of best fit, all right. A direct relationship means that as x increases, y also increases. An indirect relationship means that as x increases, y is going to decrease. We're going to see a variety of these relationships when we explore gas laws in the next unit. Okay. Controlled variables are things that we hold the same throughout. And when we're graphing, the thing that we are controlling and purposely changing is often the independent variable. And that's going to go on the x-axis, and then the dependent variable, the thing that we're observing in response to changes in the independent variable, that often is going on the y-axis. So independent on the x-axis typically, dependent on the y-axis. All right, and we will see how all of this kind of crops up in the actual graphing exercise for density, because, oh look, slopes here all right, are essentially a ratio already. And so if we graph mass over volume, the ratio will give us the density. Okay. All right. So just a smattering of some quantitative skills and definitions that we will be using in various points. And we'll come back and fill in some of those other pieces if you want it in the notes related to dimensional analysis later. Okay. Bye, y'all.